Hello, welcome to this lecture on 555 timers. So what is a 555 timer? Well, a 555 timer is an 8-pin integrated circuit that's capable of producing accurate time delays or oscillations. And there's two main modes that it's used in, but it's also used in a lot of other ways too. But the first mode is called Monostable mode. And this is kind of a one-shot delay mode where you trigger with a button and then you produce a fixed delay. And the length of that delay is defined by a resistor and a capacitor that you add to the circuit. And then the other mode is called Astable mode, which is a kind of an oscillating mode where the frequency of that oscillation and the duty cycle are both controlled with two external resistors and a capacitor. So the 555 timer itself makes use of external resistors and capacitors in order to handle timing ideas. So we'll get more into that. Let's talk a little bit about the history of the 555 timer. Well, it was originally designed by Hans Kamenzind in 1970, and it was brought to market in 1971 by Signetics, which was later purchased by Philips, and Philips is still a semiconductor producing company today. The original name was the SE555 or the NE555, depending on whether you were buying it in a plastic dip package or like a metal can package. And it was originally described as the integrated circuit time machine. And the reason for that is because it's so useful for any sort of timing-based circuits. The part is still in really wide use because it's easy to use, the price is really low, and it's very stable. It's estimated that over 1 billion 555 timers are produced every year. 1 billion. That's a lot of these. So it's an extremely useful chip, and it's used in a wide variety of circuits and products. So the 555 timer itself, like I said, is one of the most popular and versatile chips ever produced. It's older than I am, and it's a combination internally of both digital and analog circuits. So it's widely used in a whole variety of timing tasks. It's a very useful addition to any circuit designer's toolbox, we'll say, because it's capable of producing accurate time delays. It's useful for producing an oscillation or an oscillating circuit. Just has a lot of useful functionality. So some of the applications that people use 555 timers for: precision timing, where you need to exactly time how long something is going to be on; sequential timing, time delay, to delay when an event occurs; pulse generation, generating a pulse that's a specific length; pulse detector, detecting when a pulse occurs; pulse width modulation and position width modulation; an LED flasher would be a really common application, like a children's toy, and just a lot more. There's so many different things you can build with a 555 timer. So inside the 555 timer there's over 20 transistors, 2 diodes, and 15 resistors. And so it has voltage dividers, it has comparators, it has all sorts of things. And let's look at a diagram to get an idea of what that is. All right, so here's kind of an internal diagram of what a 555 timer should look like. Now, it's got a whole variety of pins, but a few things I want to point out is that it's got 3 resistors set up in a voltage divider. Voltage divider just meaning, we have 5 volts, let's say, on our VCC, and then it drops over 3 resistors that have the same value. Now, in practice, those 3 resistors are all about 5 kilo ohms. So each of them is 5. Well, that means that the voltage at the top is 5 volts. The voltage here is 2/3 of VCC. The voltage here is 1/3 of VCC, just because it's being divided across the resistors as we go along. So it also has a control flip-flop and a transistor, and we'll talk more about exactly what those are used for in a little bit. But for now, just know that we have a voltage divider, and these are connected to voltage comparators. So we're going to wait and we're going to check some inputs based on when they compare to 2/3 of VCC and when they compare to 1/3 of VCC. So let's talk a little bit more about how it works. So this is a kind of a simple pin diagram of a 555 timer. And I'm going to remove 2 of the pins that aren't particularly relevant to the discussion we're about to have. Okay, so initially, let's pretend that the output of the 555 timer is 0. If that's the case, then the output is 0, and the discharge pin is connected to ground. Whenever the output is 0, the discharge pin is connected to ground. And so we sit there, the output is, okay, let's draw a little axis here. My output is low. My discharge pin is connected to ground. And at some point, let's say that the value being inputted at trigger drops to 1/3 of VCC. So it drops below 1/3 of VCC. Well, if that's the case, then my output goes high and my discharge pin is disconnected. Later, if the threshold pin becomes higher than 2/3 of VCC, then the output goes low again and discharge is reconnected to ground. So this is kind of a summary, and at this point you're probably slightly confused as to why I'm telling you this, but when we do an example a little bit later, it'll make it more clear. But let's talk about why this happens. Why is it that different things are connected to ground at different values of threshold and trigger, et cetera, et cetera? So to do that, we're going to go back to this circuit diagram. So remember, we have our voltage divider that puts 2/3 of VCC here, 1/3 of VCC here. So okay, so we see that the threshold input is connected to this voltage comparator, which is being compared with 2/3 of VCC. So if the threshold value hits 2/3 of VCC, that triggers a reset on our control flip-flop. Well, what happens if a flip-flop is reset? Well, the output goes to 0. So let's start at 0. Let's say we're starting at 0. We'll go up later. So the output is at 0. And then the output of this is 1, but that's just because it's the inverse of the main output. So we're outputting at 0, and when this is outputting at 0, this is set to 1, so our discharge pin is connected to ground because this transistor is activated. Later, if the trigger pin drops below 1/3 of VCC, then we see that we trigger the set value on the control flip-flop. And when you trigger set, what happens? Well, the value goes high. And when the value goes high here, that means that our inverse of that would be 0, which would turn off the transistor, which would leave discharge disconnected. So this is how we get to this setup where threshold and trigger are used to either turn on or off the output while connecting and disconnecting this discharge pin. But now let's look at a specific example of using a 555 timer that should hopefully make this even more clear. So the first mode I want to discuss for the 555 timer is monostable mode. In monostable mode, the timer acts as a one-shot pulse generator. That means that you're going to use the trigger pin to initiate a pulse. The pulse is kind of a fixed length. And then after the pulse is done, it goes back to 0 again until the trigger's initiated again. So the circuit for this looks something like this. So we have one resistor and one capacitor, and they're both connected in the middle to both discharge and threshold. And then trigger is an external signal that we'll just use as an input. So the goal of this circuit is that when trigger is set to 0, even briefly, that starts a pulse on the output from the 555 timer. So our goal here is, say someone pushes a button and that causes an output pulse to come from our 555 timer. So let's say that we're starting out just like we are. The output is initially 0, and our trigger is initially high. Trigger is active low, effectively. So when we drop trigger low, that means that the output is going to go high, just like we see here. And when the output goes high, because it's a 555 timer, discharge is disconnected. So discharge is not connected to anything. There's this big gap between it and ground. No connection. Well, if discharge is disconnected, then as you can see, VCC will flow through the resistor-capacitor pair to ground. Well, if that occurs, then we're effectively charging the capacitor through an RC circuit. So if we're charging the capacitor voltage slowly increases based on the values of R and C, and suddenly it'll hit 2/3 of VCC. When it hits 2/3 of VCC, that means that the threshold pin is at 2/3 of VCC. And when that occurs, that changes the state of the 555 timer. It sets output to 0, and at the same time, connects the discharge pin to ground. Well, in this circuit, when the discharge pin is set to ground, the capacitor, which is charged, will be connected to ground. So it will immediately discharge very quickly. And that is effectively the complete end of our pulse. So our pulse went low as soon as the capacitor voltage hit 2/3 of VCC. That discharged the capacitor, and now we're back to our initial state, waiting for the trigger to happen again to trigger the pulse again. So how long is that pulse? Well, it's based on how long it takes to charge that RC circuit. And if you do the math, you can basically get this equation, which is that the length of the pulse is 1.1 times the resistance times the capacitance. Now the resistance needs to be in ohms and the capacitance in farads. So if you want to create a one-shot pulse circuit and you figure out how long you need the pulse to be, then you simply choose an appropriate resistor and capacitor based on what you have available to get the timing that you want. So if you have a really large resistor and capacitor, then you'll have a long time on your pulse. If you use small resistors and capacitors, then you'll have a short time on your pulse. So what are some uses of monostable mode? Well, it can be used to turn circuits or external components on or off for a specific length of time. You can be used to generate delays. So someone could push a button and you could use the 555 timer to create a delay before something would occur. You can cascade them together to create a variety of sequential timing pulses, meaning so you'll trigger one and that will wait some amount of time, activate a circuit, and then trigger another 555 timer, which will activate another circuit, etc., etc. So you can use pulses like this to time and sequence a number of related operations based off of one trigger push. Now another mode for a 555 timer is astable mode. And astable mode is simply an oscillator. And you may remember that an oscillator is basically a signal that just oscillates between low and high, low and high, low and high. So in astable mode, the 555 timer generates a continuous stream of rectangular on-off pulses that switch between two voltage levels, namely 5 and 0 if you're powering the 555 timer with a 5-volt input. So here's the circuit for astable mode. So now you can see that there's two resistors and we're wiring it up a bit differently to the 555 timer. So we have R1, R2, and C, and the output is going to be this astable signal. Well, let's talk about how that happens. So let's just pick a starting thing and say that initially we're outputting a 1. So let me draw my axis here so you can see what I'm doing. So initially we're outputting a 1. Well, if the output is 1, then the discharge pin is disconnected. So if the discharge pin is disconnected, then that means that VCC is flowing through R1 and R2 into the capacitor C, and it's charging it. So we'll have our capacitance slowly beginning to charge. And after it gets to 2/3 of VCC, that will set the threshold pin to say, okay, we hit 2/3 of VCC, which will cause the output to go low. Now when the output goes low, that causes the discharge pin to be connected to ground. Well, if the discharge pin is connected to ground, then our capacitor is going to discharge. But unlike monostable mode, it doesn't discharge instantly. It discharges through resistor R2. So we'll have a discharge where the capacitor will slowly discharge until it gets down to 1/3 of VCC. And when the capacitor discharges to 1/3 of VCC, then all of a sudden we're going to set the trigger pin because we dropped below 1/3 of VCC. And when trigger gets triggered, then that's going to cause the voltage to go high again, which of course is going to disconnect the discharge pin, which is going to recharge C through R1 and R2, and we're just going to continue this process of producing a rectangular high and low oscillator. So the timing of this one, how do you calculate the times? Well, you can kind of look at, when you look at the diagram, you can see that the capacitor charges through R1 and R2, but it discharges only through R2. So this means that time 1 is based on R1 and R2. So here we can see R1, R2 multiplied by the capacitance, and then 0.693, which is actually the natural log of 2, which, while interesting, is really not all that exciting to go through the mathematical derivation. So just know that it's 0.693 or the natural log of 2. So timing 1 is the amount of time that the oscillator is high. And so that is 0.693 times R1 plus R2 times C. The amount of time that the oscillation is low is based on the discharge of the capacitor through R2, which is just 0.693 times R2 times C1. So you can calculate the on time and the off time based solely on the resistor and capacitor values. Now, of course, if you take T1 plus T2, then that's the period of the oscillation. Think back deeply to electronics when you took it and thought it through. So the period of the oscillation is the time from the beginning to the next beginning. So that'd be T1 plus T2. If I do 1 over that, then that's the frequency of the oscillation. And actually, that's what this equation is here. It's 1 over T1 plus T2, and then it's reduced. So if you do T1 plus T2, 1 over that, and reduce it, you end up with this equation. So these are just 3 basic equations you can use to calculate what you need for your astable timer. So if you were looking for a particular on time or off time or a particular frequency or a particular duty cycle, all sorts of things, you can derive and decide on those based on your choice of resistor and capacitor. So there's a lot of other usage modes for a 555 timer. Way too many to discuss in this lecture. So what I recommend is you look at the 555 timer booklets that are available on Blackboard, because they list all sorts of interesting circuits that you can build with a 555 timer. Even if you just look through it for 5 or 10 minutes, you'll be surprised at how many different types of things you can build with this very versatile chip. So let's review. The 555 timer is a versatile, commonly used chip. It's useful for producing circuits that need timing of any kind. And understanding the functionality of it is going to require some more thought. Understanding how the threshold and the trigger change the output and how that relates to the discharge pin. So I recommend you look over these notes again and kind of walk yourself through both the monostable and the astable mode to make sure you understand how they work. Thanks.